Hi everyone, today we're going to do adding and subtracting polynomials. This is 7-1 in our Envision book. So we're going to start off, and I'm actually going to cover some of this up because it just gets to be too much for you to look at the same time. Okay, so a monomial is a number or a variable or a product of them. That's kind of the basic definition. And the way that I think about it is like one. We know mono means one clump. Okay, so here are some examples of monomials. 3 is a monomial, 5x is a monomial, x to the 10th, all of this, 50, x, y, z, one big clump, that is a monomial. 1/3 x to the 4th, that's a monomial. So each of those are examples of monomials. And so let me show you some non-examples of monomials. So x to the 1/2 power, that is not a monomial. And I know you're probably thinking, wait a second, x to the 10th was a monomial. It's because you can't have a fraction exponent. So the reason why this is not a monomial is because the exponent is a fraction. If you remember, that, makes it a square root. Okay, so if you look here, this is also not a monomial. Mono is 1, and if you notice here, it's like 2 clumps. This 5x is all being multiplied together, and the adding sign is showing, and then this is being multiplied. So we have 2 clumps here. So it's not a monomial because we have an adding. The same thing would happen if there was a subtracting. Okay, this is not a monomial because we have an x in the denominator. You're allowed to have a number in the denominator, but it can't be a variable. This is not a monomial because once again, we have 2 clumps separated by a subtraction sign. So that is not a monomial. Okay, so that's just to kind of give you an idea. These are monomials and these are not monomials. Okay, so I think what I'm going to do for this next section is, this is what I would do if you were in class. I would say, okay, I am going to see if you guys can figure this out. These are all monomials. All of these are examples of monomials. And we are going to figure out their degree. And I think I put, names later on. Okay, so I'm going to see if you can figure out what the pattern is. All right, so over here, I'm going to put degree. Okay, the degree of this monomial is 3. So take a look, try to figure out how I got 3. The degree of this monomial is 1. The degree of this monomial is 0. The degree of this monomial is 4. The degree of this monomial is 12. And the degree of this monomial is 8. So do you think you figured it out? You think you figured out how I figured out my degrees? I'm guessing you probably have. It's basically, I have to look at my variables and add up the exponents. So this has an exponent of 1, this has an exponent of 1, this has an exponent of 1. So the degree of this monomial is 3. That has an exponent of 1. This doesn't have a variable, so it has a degree of 0. 4 is just 4, and then 6 and 10 is 11, and that has a degree of 1. That's a z, so it totals 12. And then 7 and 1 is 8, okay? So monomials have degrees, and sometimes that's important to know what the degree of a monomial is. Okay, we'll talk about that in a minute, sorry. All right, so a polynomial. You know how before I kind of said a monomial was like 1 clump, and I showed you examples like this, and I said, oh, look, this has 2 clumps. All right, so that's a polynomial. A polynomial, it can be a monomial, or it has more than one monomial added or subtracted. So this is not a polynomial, but this is, because it's 2 monomials being added or subtracted. Same with this one here. 2 monomials being added or subtracted. Okay, and I'm going to show you a ton more examples. So now let's go back to the degree thing. So usually I think, oh, kids go through this, they're like, oh my gosh, Miss Knight, finding these degrees is so easy. And it is, it's super easy, right? You could do it. You're like, give me more questions like that. I'm going to get those right. But then here, I'm going to give you a new rule for polynomials to find the degree of polynomials, which is also easy, but it's a little different. And so even though they're both easy, they're also easy to get mixed up. So you kind of have to really slow down and say, is this a monomial? This is how I find the degree. And now we're going to talk about finding the degree of a polynomial because it is a little different. Okay? So this is a monomial, right? So this has a degree of 0. This has a degree of 1. Now here's where it gets different. This has a degree of 2. This has a degree of 3. And this has a degree of 4. All right, let's see if I put some on the other page. Okay, so how do we find the degree of a polynomial? What you have to do is you have to find the degree of each monomial, and then it's the biggest one. Okay, so we just have a monomial, so its degree is 0. We have a monomial, so it's the degree of 1. Now, if you look here, we have a monomial here. That has a degree of 2. This has a degree of 1. This has a degree of 0. Well, which is the biggest number? I said 2, 1, and 0. 2, so the degree of the entire polynomial is 2. Okay? This is a monomial, so it has a degree of 3. Here, I have to look at this monomial. It has a degree of 4. This has a degree of 1. This has a degree of 1. And this has a degree of 0, so I have to use the largest number, which is 4. Okay? And then if you notice in this last category, what we do is we give names. Okay? Names to our monomials or polynomials. So this one, if it has a degree of 0, it's called constant. If it has a degree of 1, it's linear. If it has a degree of 2, it's quadratic. If it has a degree of 3, it's cubic. And if it's any higher, you just say degree of 4, degree of 5, or 4th degree, 5th degree, 6th degree. So those are really the only ones that you have to remember. Okay, so I'm just gonna write a few down on this random sheet of paper and we're gonna see if we can figure it out. Okay, so if I gave you 5x to the 6th plus 3y to the 3rd, z to the 4th minus 8x, y, z. What's the degree of this polynomial? Okay, this has a degree of 6, this has a degree of 7, this has a degree of 3, so the degree of this polynomial would be 7, okay? All right, now we have two ways that we name polynomials. One is according to their degree, and one is according to the amount of terms they have. So if we look here, okay, number of terms. Terms are like clumps. Terms are the amount of monomials I have. So see, I have one clump here, all right? That says a 1 term. Here, I have 2 terms, so this was a monomial. This, 2. They're separated by adding and subtracting signs. 2 is binomial. Okay, see how they're separated by adding? Those could also be subtracting signs. This is 3 terms. Trinomial. And then this is 1, 2, 3, 4. 4 terms. And then once we get to 4 terms, once we get over 4, we just call it polynomial. But I want you to know these are all polynomials. This is just kind of a little more specific, monomial, but these are technically all polynomials. But once we get over 3, we don't get specific, we just call it a polynomial, okay? All right, now one thing that's important is to be able to put these polynomials into standard form. And it's a lot easier than you think. I know it sounds complicated because when we're doing y equals mx plus b, that got a little confusing. We are gonna put them in descending order of degrees, okay? So if I look here, when I'm looking at these degrees, oh, I did not mean to do that. Okay, so let me talk to you about that because I made this mistake and I didn't mean to, but I'm gonna show you. So if I had something like this, do you see how these have the same exponent value? I would combine them first. I would have 7, they're like terms, which I'm gonna get to in a minute, plus 3x squared. So now if I want to put them in standard form, I look at the exponents. They have to go in descending order. So this has the largest exponent, so I'm just going to put that first. It's positive, so I'm going to put 3x squared plus 7. This is standard form. It's just really putting it in order. All right, if you look at the next one, so I'm looking here, here, and here. Okay, this has the largest degree, so this needs to come first. Now what you need to notice is the negative is with the 8. This negative is with the 3, and the 2 is positive. So I have to put this one first. Negative 8y squared. Then this one, plus 2y minus 3. So I'm just putting it in order, and the order does not go by the coefficients or the number, it goes by the exponents, okay, descending order. And when we add, it's this, most of you guys know, and there's a few different ways to do this in the book, but we're just going to combine like terms. So all you're doing here is you're saying, well, what can I put together? Okay, so I'm going to go ahead and put it in standard form at the same time. Okay, so when I'm looking here, I'm going to say, okay, this has an exponent of 2, this has an exponent of 2. They're both positive. So 3x squared plus 2x squared gets me 5x squared. Okay, now I'm done with those two. Now I'm just going to move on to my x's. So I have 4x plus 2x, and that gets me 6x. And then I have this 6 on the end. Now, the reason why I like to do it like this is because this is in I put it in descending order. I put it in standard form already. And it is, and it's all added up and good to go. Okay? So sometimes you're going to see it written like this, and this is two separate problems. We're just taking this and we're adding it together. So I know sometimes some of my students like to they don't like the parentheses. They feel like it gets in the way. So they just, get rid of the parentheses and then say, let me combine like terms. Well, once again, descending order. I have 4 plus 3 gets me 7x squared. I have my 2x, nothing to combine with that, so it stays there. And then I have my negative 3 plus 6, and that gets me plus 3. Okay? So same thing here. Let's look at this problem. And sometimes some people will say, well, I'm not, I'm not going to, I can put it, on top of each other. If it's an adding problem, that's okay too. What I mean is sometimes people will say, I'm going to line it up like this. I don't usually tend to do this, but it's fine to do it this way. And then when you add, you don't have anything to combine that to. So you get this in, negative 2x squared. You combine your 5x and your 3x, and it gets you 8x. And then negative 7 and 7 cancel out. So you're done. But you would have gotten the same thing had you just ignored the parentheses and said, okay, nothing combines with that. Let me write it down. Those two combined together, it gets me 8. Those two cancel each other out. Okay, sometimes you'll see it like this, and this is for subtraction problems. You must remember to distribute your negative. So what's going to happen here is you're going to have 6x squared plus 3x minus 2. You're going to distribute this negative to everything. Negative 3x squared minus 5x plus 8, okay? And then we're gonna start from scratch. We're gonna say, let me put it in the right order. Well, I have 6x squared, minus 3x squared gets me 3x squared. I have 3x minus 5x gets me negative 2x. And negative 2 plus 8 gets me 6. Okay, so you have to remember to distribute that negative. That's really important. Okay, 2 more quick things to talk about here. Once again, I have a negative that I'm going to distribute. Negative 5x minus 6, I distribute that to here. Negative 4x squared, distribute it to here, negative 6. Now I'm gonna see what I can combine. Notice this is the only x squared, so that comes first. I have minus 5x. And then a negative 6 and a negative 2 gets me negative 12, okay? Now the last thing I want to talk to you about can get a little confusing. It's called the closure property. And the easiest way for me to explain it is to give you an example. It says polynomials are closed under addition. And what that means is if I add polynomials, like right here, I added polynomials, I'm always going to get a polynomial for an answer. Okay, so if it's closed, it's basically saying whatever goes in must come out. So if polynomials go in, a polynomial is going to come out. And that's what that means. Polynomials are closed under addition. Notice, polynomials are closed under subtraction too. If I put polynomials in and I subtract them, just like I did down here, my answer is also going to be a polynomial. Okay, so that property is called the closure property, something that you probably have not heard before. All right, see you guys tomorrow. Bye.